If f is continuous on an open interval AB, defined on a closed interval AB, and differentiable and differentiable so undifferentiable, then there exists a number C. There exists a number C in an open interval AB such that f prime of C is equal to 0 and f of B is equal to f of A, which is equal to 0. This is what the Rolle theorem says. So that we have now the mean value theorem. Which is the main theorem building up on Rolle's theorem. If f is continuous and differentiable, on an open interval AB and defined on a closed interval AB, then there exists a number C in an open interval AB such that f prime of C is equal to f of B minus f of A over B minus A. This is what makes the Rolle's theorem to be a baby theorem of the mean value theorem. Because the mean value theorem takes up a general case. The Rolle's theorem is a special case of the mean value theorem when f of B is equal to f of A. And when they are both zeros, then you have the Rolle's theorem. So we look at nice exam questions that uses the mean value theorem.
I wanted to see the boss. But I think you will not repeat those. And they are actually good in something. I wanted to
sorry, the previous
guys. The time I was going, it was off. And then that's when I went there to check on it. So I wanted the line.
all right, thank you. Okay.
Yeah, I've no phone, but I could not.
So
and I those who I got them
in the following, check if the mean value is satisfied, and if so, find the constancy. For A, f of x is equal to x squared plus 2x minus 1 when A is 0, B is 1. Then B, f of x is equal to x plus 1 over x. A is half, B is 2. Then you say, okay, solution. The mean value theorem requires that f prime of c be equal to this by b minus a.
That's great. No, that's great. You know, from that time we applied this school.
So
I did not proceed.
we check
You applied
what is f of a.
and at that time when we were
F of a is f of 0.
Nice
Which is negative 1. F of b, f of 1, which is 1 plus 2 minus 1, which is 2. And then b minus a, that is 1 minus 0, which is 1. Then is f differentiable? The derivative is 2x plus 2. So f is differentiable. It's continuous on the interval 0, 1. So now we'll do f prime of c, which is this, should be equal to the so f prime of c is going to be 2c plus 2, but we are saying it should be equal to f of b, or I can do this down. This implies that 2c plus 2, which is f prime, is equal to this. F of b is 2 minus f of 1. F of 1 is negative 1. I mean f of a over b minus a, that is 1. So get 2c plus 2 is equal to 3 over 1. So that we get 2c is equal to 3 minus 2, which is 2c is equal to 1. Divide by 2. So we have c. It was not even squared. So c is equal to half. And if you check, half is found in this interval. So it makes sense for half to be c, because it must be found in that interval according to the statement here. statement says C should be in an open interval A, B. So it should not be equal to A, it should not be equal to B. Any questions here? Okay, let's go to B. F of X.
Me, I've just joined it. So I had the network challenges.
Okay. So you can run here through. So the question is asking us to check if mean value theorem of this F is satisfied. If so, we should find the constant C in the mean value theorem. And the mean value theorem is this one here. So now you start finding its component. So you find F of B. F of B. Now B, between A and B here, we get this 1. So we get 2. We come back and get F of A, which is -1. We're substituting in the original question. So you get -1. Then you get B minus A. So 1 minus 0. You get 1. Then you do F prime. We also want to use F prime. So we get F prime, which is 2x plus 2 here. And then you come here and say F prime of C. F prime of C. So now in this one where there is X, you put a C. So you have this. And then now we have this equal to, you substitute here, 2 minus 1 over 1. So we have 2C plus 2 is equal to 3. Then take this other side, you get 1. And divide by 2, so you get C is equal to half. So this is how you get.
Yes, he was asking for stem cell.
Okay, thank you,
He
sir.
was asking for stem cell. He said, I don't want. So when I checked this, when I realized that actually.
So you go to B. F of X is equal to X plus 1 over X with interval half, comma 2.
There's someone who got
This is the interval. Well, we differentiate the function first and see if it is differentiable. We'll get 1 minus
Sir,
1.
just mute everyone. Just mute everyone.
And I think it's not in the group, it's in my background.
Oh, sorry.
So it's I can't control.
Okay. You don't have also.
So you could write this as the x plus x to the power -1. So when you differentiate, you get 1 minus x to the power -2, which can be written as 1 minus 1 over x squared. So we have 1 minus 1 over x squared as our derivative there. Then we find f of half. So f of half is going to be half plus 1 over 1 over 2. This is half plus 2 over 1. So that we get Is it 5? Yeah, we get 5 over 2. And then we do f of 2. That will be 2 plus 1 over 2, which is again 5 over 2. Then b minus a, we get 3 over 2. So I have these critical numbers. So if you look at the question, it has now become, it's a mean value theorem, but because those two are equal, though they are equal but not zeros, it will behave as if it's a Rolle theorem. Just as if, not that it will be. So f prime of c should be f of b minus f of a over b minus a. So f prime of c is equal to 0, of course, because we'll subtract the numerators there. 5 over 2 minus 5 over 2 over 3 over 2. That will be 0. Then now we go to f prime and substitute where there is x. We put a c there for us to be able to find what that c is. So we're solving an equation of this nature, c squared. We do it from here, we cross multiply, we get c squared is equal to 1, and then square root. So we'll have c is equal to plus or minus 1. Now, if c is plus or minus 1, then this means that, looking at the interval there, c must be, remember we said c must be a member of the interval, half, comma 2. So between -1 and +1, you realize that +1 is the one that is a member of the interval half, comma 2. So we say therefore, yeah.
Yeah.
Okay, check if your phone. Okay, so this means that the solution therefore is c is equal to +1. Any questions? Here's another nice question. Question 2. Decide whether the mean value theorem applies to the given function on the given interval. If it does, find C. Part A, f of x is equal to 25 minus x squared. That is from -5 to +3. So let's check. The first thing you check here is if you can get the derivative. That is going to be half 25 minus x squared to the power -half multiplied by -2x, which is 2 here 1, 2 here 1. So you get -x over the square root of 25 minus x squared. So it is differentiable. What about f of -5? Is it defined? You get 25 minus -5 squared, giving us 25 minus 25, which is 0. What is f of 3? That is the root of 25 minus 3 squared. So we get 25 minus 9. This is 16, which is 4. And then what is b minus a? That is 3 minus -5, which is equal to 8. These 4 important numbers. So say, okay, f prime of c is then equal to f of b, which is 4, minus, maybe we do f of b minus f of a over b minus a. That means that f prime of c is equal to 4 minus 0 over 8. This is the same thing as saying, what is f prime of c? F prime is here, so substitute where there is x, we put c. The root of 25 minus c squared is equal to, this is 1 over 2. We cross multiply, we'll get -2c is equal to the square root of 25 minus c squared. So if we square both sides, we realize that we're getting 4c squared is equal to 25 minus c squared, giving us 5c squared is equal to 25 square root. Before we square root, we divide by 5. We divide by 5. We'll get c squared is equal to 5. And then we square root. We'll get c is equal to plus or minus the root of 5. We got the interval given. The interval is -5, 3. So you find both positive root 5 and negative root 5 as part of the interval. There. So when I was preparing for the part that for linearization, I discovered that it needs a bit of this theorem. So that's why I had to say today we'll look at this theorem. Come in. Yeah, I can still come in. Yes. Okay. She's not. Okay. So let's see why we had to look at it today. So I'm recovering slowly. Slowly, don't go too far. I can give you an exercise here. A nice one, which will be B. For this one, you check if the Rolle's theorem is satisfied. Check the Rolle's theorem. If so, find C. The function will be 2 power 2x plus 1 minus 3 multiplied by 2 to the power x plus 1 on the interval -1, 0. And then on the mean value theorem, I give you f of x. Let me put it the way it's here so that we also have a variety of variables. 1 over t minus 1 on 0, 2. For each case, find C after you have checked that the theorems are satisfied. Have you find the answer? You can post in the group for others to comment, to compare what they will find.
Are we finding it right now?
No, you do it when it cuts here. I was just giving them for screenshots. Okay, so we'll end here.